Welcome students. In this video we are going to discuss the difference between ionic bond and covalent bond. First we see what is meant by ionic bond. The bond which is formed by transfer of electrons, that bond is known as ionic bond. The example is sodium chloride. How sodium chloride is formed? Let us discuss it. The atomic number of sodium is 11. Its electronic configuration is 1s2, 2s2, 2p6 and 3s1. That is, in first shell there are 2 electrons, in second shell there are 8 electrons and in valence shell there is 1 electron. Therefore, its configuration is 2, 8 and 1. And according to octet rule, every atom has the tendency to attain nearest noble gas configuration. And therefore, sodium has the tendency to lose 1 electron, and sodium loses 1 electron and converts into sodium ion. Its electronic configuration becomes 2 and 8, that is, in outermost shell there are 8 electrons, that is, its electronic configuration is stable. Now towards chlorine atom. In case of chlorine, its atomic number is 17. Its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. That is 2, 8 and 7. In valence shell or outermost shell there are 7 electrons, and to attain stable electronic configuration, chlorine has to gain 1 electron. It has the tendency to accept 1 electron, and chlorine accepts 1 electron and converts into chloride ion, and it attains the noble gas configuration, that is 2, 8 and 8. In that example, sodium loses 1 electron which is accepted by chlorine atom. After losing 1 electron, sodium converts into sodium ion, that is cation, and chlorine converts into chloride ion, and thus two oppositely charged ions are formed, sodium ion and chloride ion, and there is a electrostatic force of attraction between sodium and chloride ion, and due to electrostatic force of attraction, sodium chloride is formed. Thus, the bond which is formed by transfer of electrons, that bond is known as ionic bond. In that case, there is a transfer of electron from sodium to chlorine takes place, and this is the formation of sodium chloride. Ionic bond is also known as electrovalent bond, and the compounds which contain ionic bond are known as ionic compounds. Another examples of ionic compounds are like this: potassium chloride, magnesium chloride, etc. These are the ionic compounds. Now let us see formation of covalent bond. The covalent bond, that is the bond which is formed by sharing of electrons. In ionic bond there is a transfer of electrons to attain the stable electronic configuration, and in case of covalent bond the sharing of electrons takes place to attain the stable electronic configuration. The simple example, that is formation of hydrogen molecule. In case of hydrogen, its atomic number is 1 and its electronic configuration is 1s1, that is, in hydrogen there is only 1 electron. To attain stable electronic configuration, it must complete its duplet or octet, and to complete its duplet, these two hydrogen atoms share their electrons to each other. This hydrogen and this hydrogen share their electrons to each other, and the bond formed, that bond is known as covalent bond, and we know that the covalent bond is shown by a dash. Such type of bond is known as covalent bond, which is formed by sharing of electrons. This is formation of hydrogen molecule. Formation of hydrogen chloride. In case of chlorine, its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. That is, its electronic configuration is 2, 8 and 7. In the formation of hydrogen chloride, hydrogen has 1 electron in outermost shell, while in case of chlorine there are 7 electrons in outermost shell. In case of chlorine there are 7 electrons in outermost shell and they shares their electrons with each other. And after sharing of electrons, hydrogen completes its duplet while chlorine completes its octet. Thus, both hydrogen and chlorine attains the stable electronic configuration, and such type of bond is known as covalent bond, the bond which is formed by sharing of electrons. This is formation of hydrogen chloride. In case of organic compounds, covalent bonds are seen. Now we see the formation of methane molecule Ch4. The formation of methane molecule. In case of methane, carbon atom is in sp3 hybridization state. That hybridization we discuss in sp3 hybridization lecture. Only remember that in sp3 hybridization state, carbon have 4 electrons, 4 unpaired electrons in sp3 hybrid orbitals. There is mixing of 1s and 3p atomic orbitals, and after mixing 4 sp3 hybrid orbitals containing single electrons is obtained. Atomic number of hydrogen is 1, there is 1 electron in its shell. To attain stable electronic configuration, carbon requires 4 electrons to complete its octet and hydrogen requires 1 electron to complete its duplet. Therefore, carbon forms the bonds with 4 hydrogen atoms. These are the electrons of carbon atom, 4 electrons of carbon atom, and it shares its electron with electron of hydrogen atom, and thus 4 CH bonds are formed. That bond is of the type covalent bond because the bond is formed by sharing of electrons. And in case of sp3 hybridization, to minimize electronic repulsion, that hybrid orbitals orient in space tetrahedrally. Thus, the structure of the methane is tetrahedral and the bond angle is 109.28 degree. In case of organic compounds, carbon forms the covalent bond with other atoms, and that is the difference between ionic bond and covalent bond.